Good day, everyone. So today's lesson is a review of functions. Okay, so let us define first what is function. Mathematically, let's define this. Okay, function, so we're going to let x and course y be non-empty sets. A function from x to y is denoted by f. So x arrow y. This is a rule that assigns to each element of x a unique element of y. Again, this is a rule that assigns to each element of x a unique element of y. So that is function. So the set x is called the domain of f, or in symbol usually we use domain f, while the set y is called the codomain of f. Note that all elements of x must be assigned to some elements of y. Not all elements of y are necessarily assigned to some element of x. So the set of all elements of y that are assigned to some element of x is called the range of f, or the range of the function. I'll repeat. The set of all elements of y that are assigned to some element of x is called the range of a function. Usually, this is denoted by RAN f, or range of the function. So, you have to take note of domain and range. Okay, I hope you understood the definition of the function. So the function now is denoted by, of course, y is equal to fx. Okay, so that is now the denotion of the function, because the element or the value of y depends on x. So we say that x is the independent variable, while y is the dependent variable. So a function may be viewed as set of ordered pairs x, y, where x, y are elements of your function if and only if your y is fx. Okay, in this course we shall be considering the functions that are called the real valued function of a single variable. So it means that the codomain of such function is the set of real numbers denoted by R. Okay, so that is real numbers. In particular, we will be concerned mainly with the function whose domain is a subset of this real number. Okay, so that is the review of our function. Okay, the definition of a function, just to refresh you with what is function. So let's consider an example of understanding more of what is function. So we're going to consider the function defined by the rule. Say for example, we have function of x is equal to x squared. Okay, so the expression x squared is a real number for all x, are all elements of, are all real number. So domain of a function, of course, are all real numbers. On the other hand, since x squared, if we're going to take note class, x squared is non-negative. Why non-negative? Because if you're going to substitute everything, the even negative number, the result is still positive. So for example, negative 1 squared, that is positive 1. Negative 3 squared, that is 9. So that means x squared is non-negative for all x, for all elements of x are all real numbers. So therefore, the range now of the function, if we're going back, this is the denotation, the range now of a function is that it starts with 0 until positive infinity. So that is now the range of the function. Okay, let's consider another example for the domain in the range. Say for example, I have function of x, or function is equal to x squared minus 2x minus 3 divided by x plus 1. So if you're going to look at it, this expression is the expression defining the function rule will be undefined if your x here is negative 1. Why? Because there's a rule that there should be no negative, there should be no 0 in the denominator to be able to become a function. So if we're going to substitute negative 1, so negative 1 plus 1 is 0. So dividing the numerator by 0 will become undefined. Okay, so there's no value for it. So the domain now, so the domain of the function are all real number except negative 1. Okay, so that is the domain now. Then what about the range? So the range of the function, if we're going to evaluate that, all real numbers, the same, all real numbers, okay, except for negative 4. How did you get negative 4? Since the expression x squared minus 2x minus 3 over x plus 1 never attains the value of negative 4. Again, it never attains the value of negative 4 for any value of x. So, hindi ito na-attain yung negative 4. So, that's why the range now is this one. So, those are, of course, the domain in the range of x squared minus 2x minus 3 over x plus 1. Okay? So, if you have questions, or if you have clarifications, you can comment down below so we can discuss it in the next video. Okay, so we have 0 of a function. Discuss also 0 of a function. What about 0 of a function? Zero of a function is, of course, 0 of a function means the value of x is, of course, 0. Okay, that is the zero of the function. What about the graph? This is only a review because I know we've taken this already. What about the graph of a function? Okay, so the graph of a function is the set of all points x, y. So sabi natin, it's an ordered pair also, x, y, in the Cartesian plane for which x and y are elements of the function. Okay, so how do we check if a graph is a function? So we use the vertical line test. If you still remember the vertical line test, so you can review this, to check whether a graph is a function or not function. Okay, so far, this is only a review. So next video, I'm going to discuss with you the basic types of functions. What are the types of the functions? So in passing, we're going also to discuss the evaluation of the function before we proceed to the limits of functions. So I hope you learned something from this video. So if you have questions, you can type or you can comment down below, so we can clarify it in the next video. Okay, thank you so much for participating.